So welcome all. Am I audible? Can anybody please confirm? Am I audible? Am I audible? Can you write please yes? Thank you very much. I got this response, and let us continue today's lecture. This is lecture 10, session 1. In this lecture, we are going to talk about the logical agents, and that are very important in terms of the designing a artificial intelligence system. So today's class is going to be very special in that way that we think that the humans are actually logical. They have some techniques to perform some logic, and therefore they can do various things. Before coming to these things, I think it is worth mentioning to remind you that we have earlier talked about an agent that is rational agent. So what is the rational agent? Rational agent is one which does the right thing provided some information. So whatever information is available to him, based on that it performs the right thing. It may be possible that the information itself may not be sufficient, and therefore my agent may be doing wrong thing. Okay, so we are going to talk onto the similar line where there is some information available to the system, and system is trying to come up with a strategy that what he should follow based on the information that is available, and therefore tries to do the best thing that he can. As I earlier told you, that it may be the scenario that whatever best the system is doing is not the absolute best. Please try to understand this fact, because absolute best can only be done if you know every information that is available. But nobody can have all the information, because information is infinite. So you cannot have the infinite information. Therefore, whatever limited information you have, based on that you are going to perform something. It is very interesting to note that if assume that you are not a human, then and you are trying to understand that why humans are good. So it may be possible that you come up with this particular kind of conclusion that human, it seems to know things, means looks like that they know something, and whatever they know, based on that they can do some reasoning and thinking, and therefore they can produce some more things. So this is a very important thing to understand, that humans, because whenever our ultimate goal is into the artificial intelligence system, build systems that are more near to the humans. So therefore, to make our systems near to the human, our system should be able to mimic some of the property as in human. So we see that one such property is that the human can think and reason. And how can they think and reason? Based on some of the knowledge that they have. And this knowledge base, in crude terms, we can say that these are some sentences. So some sentence such as today is the October 10. This is a sentence. So it is a right sentence because you know that this is the information that is given to you. Today is the October 10. Okay. So whenever you define the sentence, you must have to follow some rule, because if you are going to represent these things into the computers. So into the computer would only understand that when you are specifying the things into the right manner. We have various languages, C, C++, Java, etc. Different languages we have. All the languages define that how you should say something with respect to the computer. When you are talking with the computer, what should be the right way to say something? What is the correct way to say something? So similarly, if you have some knowledge, so you must have some way to represent, and this is how you are going to write the things. Okay, that thing is important, and sentences are derived from the knowledge representation language. Means there is some language that tells that whatever information you have, how you can write that information. Alright, sentences are derived from the knowledge representation language. Means if you have some knowledge and you want to present that knowledge into the system, then what should be the way to do it? That there is somebody is going to, so there should be some formal method, that is knowledge representation language, that actually specifies that how any particular knowledge can be said. Okay. So and then there would be two kind of things available to you. One, that the information that actually is given to you as a knowledge, and the second thing, that you come up with the knowledge, because some knowledge is given to you, and using those knowledge you come up with something. So let me construct such an example. I don't know, that I have not tried it, but let's assume that I give you that today is the 10th October, okay, and today is the, say, Wednesday. So what is the day on 7th? Let I want to find out what was the day on 7th. Okay, so there is one information. What is the information? But there is one axiom, understanding, that today, what is the 10th of October is Wednesday. This is the axiom, because there is no derivation. But if I ask you that what was the day on, say, 7th of October, okay, how would you tell? That you would see that what was the day before. It was Tuesday, and the date was 9. Then Monday it was 8, and therefore on the Sunday it was 7. What you have done? You have done a deduction. So when you come up with a deduction, again you find out some knowledge. And this knowledge, what is this knowledge? That on the 7th of October it was 2018. It was Sunday. And this information is, but this information is not axiom. Why? Because this information has come because of some processing that you have applied into the data. So do you understand this? Are you with me? Is it right? Correct? That initially some information can be provided to the system, and that information is called the axiom. But for them, we understand that they are true, and we don't ask that how to come up with this. But if you derive something, then I can ask the proof. What is the proof? Because if you say on 7th of October it was Sunday, I can ask that what is the proof. But if I ask that what was the day on the October 10, then you did not to ask, because it was given to you. It is an axiom. So axiom is also a sentence. Axiom is also a sentence, and they actually constitute the knowledge base. In the knowledge base, then knowledge base can apply the thinking or reasoning, whatever we call it. Then by this, it can come up with the other things. Okay. So therefore, you can understand this into this way, that whenever you want to develop a logical agent, you have to provide him some information, some knowledge. Okay, these are the information that is provide that 10th of October is 2018 is Wednesday. This is the kind of knowledge given to you. Then there is some inference engine. Means there should be some logic that given this thing, how can I modify? Because this information would be like that when I subtract one day, then the date subtract one date, then the day is also subtracted by 1. What is the relationship? After 7 subtraction, the things would be circular, because after Sunday, what is the day before this particular date? These are the logic. These comes from the logic, and these logics are actually taken care by the inference engine. So given some information, there is some inference engine, and this inference engine is actually independent of the domain, because whenever some information is given to you, it is related to the specific domain, that these are the things related to my work, and therefore this information is given to you. But the inference engine that works on this, that may be independent, because you know that addition, subtraction, all these things are into the part of the inference engines. Then they are domain independent, and they are independently can be applied to any particular scenario. All right. So when you build such type of system that have knowledge base and that have inference engine, and you want to build a system around it, how your system is going to interact? Your system is going to interact using these 3 kind of operation: tell, ask, and tell. So there is a tell, ask, and tell is a sequence that you are going to execute. What do I mean by this? I mean by this that okay, let me just take a print out. Let me tell you what do I mean by this. All right. So what I wanted to say is this, that Alright. So what I was telling that this is the system that we have. Okay, let me remove this thing. That this is the system I have where I have some inference engine and knowledge base, and this then let me also take this particular part away. I have to apply these three things. These three things are important. So let me just remove all these so that we have a space. So you know this thing that whenever we develop a system, this is our system. Okay. From the outside, can you see that there are two parts? No. From the outside, it looks like that there is some system. So all these things are there. All these things are knowledge and inference engine is there. So this system, what is the responsibility of this agent, system or agent? What is the responsibility of this agent? That the responsibility of this agent that it would behave. It would behave into some environment. So there is some environment around it. So what is the particular assumption that there is some environment around it? So what this agent would do? Agent would do a sensing. Agent would sense something. What is happening around? Based on its based on whatever kind of percepts available or the sensors available, it is going to sense something. And after sensing something, it tells to this particular inner system that this is what I have sensed. Okay, this is what I have sensed. So this is the first part. This is the first part tell. This is the first part tell that I am telling to the system that this is what I have sensed. Okay. Then what would happen? The system would do some processing, lot of processing. The system would do some processing to understand. Acha, I am into this situation now. This all has been told to me. Then what should be the next thing? Okay. This is after telling it is an asking procedure. Control that. After telling it is an asking scenario. That tell me that what I should do. And the question is that tell me what should I do. Okay. Then this ask is a big problem, because to do the ask, the system have to do some lot of processings, and after processing it would come up with the output that okay, this you should do, this particular action you should do. Take. The system is going to tell you that this particular thing you should take, this particular action you should take, and this is what the tell is. Again, the third tell is this. And the system is going to tell you that this particular action you should take based on the things that I am going to see, based on the my own scenario, based on the input, based on your sensoring things. This action you should take. Then what would happen? There would be some actuators. Okay, there would be some actuators. Actuators. What are the actuators? There would be some actuators, such as there is some wheel that is moving. And those things you can on and off, you can switch on something, you can actuate something, means you can change the environment, you can do something so that the robot moves and performs some operation. The actuators are those things that which are on and then they can perform. So when the system tells that this is what you have to do, system tells to the actuators. Okay, so system tells to the actuator that okay, you should do this, and now the system would perform something. And into the next scenario also, the sensory organs would start working, and they would again tell that whatever you have told I have performed, and now this is the new scenario. So therefore the system would tell that what next to do. So can you see this? It's easy, straightforward, that how you should go. So a logical agent would have some axiom provided, and based on that axioms or sentences, it would do some inference, and by this inference it would come up with the some output. And when we are going to see from the perspective of the system perspective, then it looks like that there are some sensors that are providing the information, because all the things are available with the system. Then these things are providing the current information to the system, and now the inference engine is trying to find out what should be the next thing, and then it is a kind of thing that what action I should take. Then it would tell the action, and that action would be told to the actuators, and actuators would perform those operations. So if you want to write it as an algorithm, this is an algorithm that is a KB agent, means a knowledge base agent algorithm, and this is not very difficult to see. It's very simple 3-line algorithm, and KB means knowledge base agent that is provided some percept, means something is provided to him, the transfers information is given to him. Then there is a procedure called tell, that actually tells means it make percept sentence given the percept and the time. There should also be a notion of time, because whenever you are performing something, time is always required, so that you make the thing sequential. I have done this and this and this, therefore there should be some understanding of the time. So one more parameter is there, that is time. Initially the time is 0, and when the agent one by one perceives something, then it updates the value of time. Means after every step the value of the t is actually updated. So initially the t is 0, we assume this. So some system initializer, when the system is initialized, the value of t is set to 0. Then we make percept sequence, so that make it in the proper format, so that we can supply to the knowledge base, and then it is supplied to the knowledge base, our engine, and then the engine does something, and then we call the procedure ask, that tell me that into this scenario what should be the right thing to do. Okay, then we see that this action we should take. The same action is given to the percept, given the time, that at this time you should take this particular action, make action sentence, and then with respect to the knowledge base, then you tell to the actuators, and the actuator take that action, and you keep this happening. These 3 steps you keep happening, so that your system perform well. Okay. Now the question is that how would you, very important and simple question, that how would you provide this kind of knowledge, because this knowledge needs to be provided. How would you provide this knowledge? There are 2 approaches. One is the declarative approach, that tells that whatever you want to tell the system, all the things should be written as a simple statement. So everything that you want to tell the system, it should be a statement, and one by one all the statements are given to the system. And second thing could be that you write a program. What is the meaning of program? It's a kind of regular expression. Program are a kind of regular expression, and when they are parsed, they generate various different kind of statements. So similarly, the second would be that you write a program, and the program has some logic, and by which maybe sometime it may be possible that using lesser number of entropy you can define the same thing. Okay, so there are two ways to define this knowledge, to provide this knowledge to the system. So we have seen from the very high level perspective that how we can build the logical agent. So logical agent, we have to provide some knowledge, and we have to develop an inference engine that when asked, given some percept, should be able to provide me that what action I should take the next, and that action would be taken. There should be sufficient actuators should be there that would utilize that thing to give me the answer. All right. So we are going to see a very interesting example over today, and this example actually tries to implement a logic-based agent, a logical agent, and this agent have some properties. So we are going to discuss these properties and try to see that how this particular agent would behave and how he can solve his particular problem. Okay, so this we are going to call this as a Wampus word, and in the Wampus word actually it is a discrete environment where there are some cells. Every cell is actually representing something different. So this is a Wampus, means if agent goes into this particular cell, so he would die because the Wampus would kill him. Okay. So this is the one thing, that in some cell there is some Wampus, and also there are some places where there is a pit. So if your agent goes into that particular pit, so what would happen, that the agent would be stuck into that particular cell, and it cannot come out of this. This is the assumption, that if your agent comes into this thing, then he would not come out. Why agent is here? What is the purpose of here? Because so many problems is there. Pit is there. He can be trapped over here. He can be eaten by or killed by the Wampus. Then why he is here? He is here because there is somewhere there is a gold. Then he want to find out that gold. Okay, he want to find out that gold. So therefore he have to take risk, because if you want to find out the gold, then you have to take a risk. So my agent is going to take the risk, and how we are going to measure his performance if he gets the gold, because gold is there, if he gets the gold, then plus 100, he gets 100 marks. And if he dies, then minus 100 means he had been killed. And whenever he take this step, then we say that this is -1, means he is actually he is spending something, so he is kharcha kar raha hai, so then it is not good. So a good agent would be such that actually find the goal in lesser number of steps. So to encourage this, to ensure this, we have put this thing, step is equal to -1. There is also one thing, that is the arrow. What is arrow? Well, sometimes it may be possible that your particular agent is actually into the bad scenario, and he is somewhere being very near to the vampus, and he find out that there is no way to forward. So at that time he can kill the vampus, but he have only one arrow. Okay, how many arrows he have? Only one arrow. So he can shoot in the arrow. So where he can shoot, for example, if he is here, so he can shoot up, down, right and left. So he can shoot into that direction. So if vampus is here, means vampus is, because if he shoots the arrow will only go into the next cell. Okay, it would not go indefinitely. So go into the next cell only. So if he sees that there is some, if he uses the arrow and fires it, so if there is a possibility that there is vampus, or it may also be possible the vampus is not there. If vampus is not there, the key actually his arrow is gone. But if vampus is there, then he get a screaming sound, because vampus is going to die and therefore he is screaming. So he have a sensor that can sense that whether there was a screaming sound or not. So if he find out that there is he have shoot in a particular arrow and he saw that there is a screaming sound, he says that okay, then it means that he is confirmed that the vampus is dead. And there is only one vampus. Okay, please understand that there is only one vampus. And also you should understand that the purpose of this particular agent is not to kill the vampus. No, his purpose is to find out gold only. So even if the vampus is live and not live, it is not a big thing. Sometimes it may be possible the vampus sitting in such a way he cannot move. Then, and in those scenarios, he should shoot the arrow. So therefore, this particular shooting arrow is actually -10. Tells that you don't want to shoot it because it is going to cost you. Okay. So the environment is such that also there is some other problem, other characteristic of this environment, that smell around the vampus. Means if there is vampus, so you have some smell, some bad smell, stench is into the nearby all the cells. If he is here, so therefore stench is here, stench is also here. So all nearby cells are having stench. Direct neighbors are having stench. And similarly, breeze around the pit. If there is a pit, then there will be some breeze. The breeze is here. So you see that if the pit is here, so all four places there is breeze. Alright. So you say the environment is such that smell around the vampus and breeze around the pit. And what are the actuators? Means what you can do. So he can do these. He can rotate, turn left and right. So he can turn left and right and go forward. If he can turn left and right and go forward, so he can go anywhere. Okay. Grab means he can pick something. So he can only pick the gold. He would only pick the gold, nothing else. And release. Sometimes if he have a gold, he can put it somewhere. Shoot means if he want to. Sometimes he want to shoot the vampus. And similarly, he have the sensor related to all of these things, such as breeze. Where there is a breeze or not, he should be able to know this. If there is a glitter, if there is a gold, then there would be a glitter. And if there is a glitter in some room, it means that there is a gold. Then he would go for the grab, and therefore the gold is taken by him, and then he can move away. So similarly, he also have a sensor for the smell. Means he can identify that whether there is stench or not. Bump. Okay. Bump means what may happen that when he is here, when your agent is here and he want to go into the right hand side. So if right hand side there is wall, so he would understand that okay, I cannot go there. So therefore he would feel a bump. So there is a sensor for the bump. Then therefore he would not go into that particular direction. Okay. Scream. As I told you that when it is a voice sensor that actually tells you that whether this particular vampus has killed or not. All right, this is the story. So now you are given this problem. Now you have to solve this particular problem. But how would you solve this particular problem? Means your agent want to find out the goal. Okay, very simple. So let us also discuss something that are technical to artificial intelligence, because we are studying artificial intelligence. We have to know whether the environment is observable. I am telling that it is not observable. How? Okay, I have some questions. Let me just take them. First, tell in from percepts to system, and second tell is from system to actuator. Yes. Okay. First tell is from percept to system, and second tell is from system to actuator. System to actuator. You are all right. Okay. The question is a rational agent is a kind of logical agent? You are right. Okay. Because rational agent is actually rational. The question is a rational agent is a kind of logical agent? I am telling from very beginning that rational agent is one that does the right thing given some information. And what is that information? This is the information. This is the information. We have not talked about that how we can make it. Today we are going to talk about that how we can make it. Given some information, how can it find out inferences? So we are going to talk about this here in this class. We have also talked something about the rational agent, but more details are here. Okay. So now can you answer this question, that is whether the word is observable? Don't see this. No. Why it is not observable? Because when the system is here, he did not know that what is into the other cells. He can perceive something, but he don't know that what is where. Okay. This is not observable. Okay. All right. Is it deterministic? Deterministic is one when the things are not changing. Yes, it is deterministic, because when there is a, as I am telling that vampus is there, so I am not telling that vampus is moving. There is a pit, I am not telling them pit is moving. Gold is not moving, nothing is moving. Therefore, things are deterministic. Okay. Is it episodic? Do you know what is episodic? Episodic means something, some 5-6 steps I can always perform, and then I can take the another 5-6 steps, and there are few steps, they are fixed. So it's called an episode. So one episode I can go play, then another episode I can play, kind of thing. Then I can mix and match. It's not episodical, because whenever you go here, you cannot tell that whenever I go into the right hand side, then I would go up. These things are not there. So therefore, every movement is independent, and then therefore it's not episodic. All right. Is it static? Yes, it is static. Things are not changing. Discrete? Yes, because if from this state you would immediately go to the different state. In between there is nothing. In between the states are not there. Single agent means are a multiple agent. How many agents are there? You see that there is single agent that is trying to find out something best out of this. So it is a single agent environment. All right. So let us try to see and try to solve this particular problem, that how we can solve this particular problem. Means my target is to find out the goal. How can I find out the goal? How can I means my agent is going to find out the goal. So the one thing that agent is initially into this state, means this state, and it is okay. Okay, this state is okay, because he knows that I'm here, so I'm fine. Otherwise, I'm killed. So vampus is not here. It is okay. It is okay. So therefore, this state is okay. Now he want to find out that where should he go. Okay. He should not go at the two places. Where? He should not go to the pit, and he should not go to the vampus. These two places he should not go. So can you tell me that whether here at this particular 2-1 there is a vampus or pit? The answer is no. Why? Why? How can you say that there is no vampus or pit? Because if there has been a vampus, then in your cell there should be some stench. Okay, there should be some smell, but you are not feeling any smell. So what you would do, I actually forget to mention this thing, that whenever you are into this state, you would find out all your percepts. And what are your percepts are? I told you that these things are there. All this information is given to you. Breeze, glitter, smell, bump, and scream. All these inputs would be given to you. You see, breeze is 0, glitter is 0, smell is 0, bump is I think with respect to the direction. If your direction is this, the bump is 0, then scream is 0. Okay. So scream is 0. There nothing is there. So therefore you find out that okay, if nothing is there, it means that this particular direction is a safe direction. You go into this particular place. Alright. So you say that this particular place is safe. Similarly, you can also see that this particular place is also safe because nothing is there, so therefore vampers and pit are not here. So similarly, you can say that this is also okay. Okay, let me just see that. Do we have something? Okay, 1 minute. All right, I don't have a question. Okay. So from this place, so you say that these two places are okay. Then you have to take a call that in which place I should go. There is some randomization, maybe by randomly you picked up that I am going to into this place. So now these two places are okay, these two places were okay, and you have decided that your agent would move into this particular cell. It would again go for the percepts, means try to see that what is around. He sees that breeze is there, because he is into this set, he said the breeze is there. So breeze is there means what? Okay, I have a question. There can be a situation when both places are not okay, but one place is actually safe. What to do then? So when both the places are not okay, but one place is actually safe. They are not okay, then how can safe? What do you mean by this? Okay. So then look, if it is not okay, then it's not safe, na? There can be a situation where both the places are not okay, like there is a breeze in first box. All right. If you say that there is a breeze in the first box, then you cannot say that these things are okay. Okay. By yourself, based on your percept, you cannot tell this. Okay. Then you would be stuck because this is the problem. If there is a breeze into the first cell, then you would be stuck. You cannot move because you cannot take the chances. Right? It depends upon that how much chances you are going to take. So let's assume that we don't want to take the chances. Then it's not right thing. You would not be able to move anywhere. All right. So I was telling that I am into this scenario. I am into this. I am into this position. I am into this position, and I saw that there is a breeze. So what would happen? But I don't know that where is a pit. But I know that pit is not here. I know that pit is not here. But pit could be here. It could be here. It can both at any of the places. So I put that question mark that there could be a possibility of pit. And then where should I move? The same question that you were telling, that like there is a breeze. If there is a breeze, where should I go? You cannot go anywhere. There is a problem. You cannot take the risk. Then what would happen? You have to come back. You have to come back here. And then when you come back here, then you decided that since this particular path has been traversed, you would go upward. So here we are into this situation where you see that your agent is here now. What he sees, that stench, there is some stench. Okay. So again there is a problem. Okay. What is the problem? That there is a smell. Because of the smell, what could be possibility? Smell, what is the possibility? That you see the vampus is near. So where could be vampus? Vampus could be here or vampus could be here. Okay. Vampus could be at both the places. Okay. Are you with me? Do you understand? At both the places vampus could be there. But now you can apply the inference and tell that if vampus has been here, then at this location also you have got a stint. Okay. But when you are into this cell, you didn't saw that there was any stint. It means that this particular possibility that vampus is here is not there. All right. All right. What does it mean? That vampus could be Vampus could be into this position only. Okay, but I'm not sure about that. But Vampus could be at this position, but Vampus could not be here. So therefore, you say that this location is also okay. Do you understand this? Should I explain more? Once again, let me tell you that when you are into this state, you find out that there is a string, and therefore you saw that there is a possibility of Vampus of here and here. But since you know that when you are here, that time there was no strings, therefore the Vampus cannot be here. Therefore, the only possibility for the Vampus is here. And definitely it looks like that Vampus is there because only one possibility is there, so therefore Vampus would be there. Okay, but your task is not to kill the Vampus because at this position you can shoot an arrow also, but you would not do that. What you would do? You would find out that there is one okay position, you would move to this particular location. Okay, you would move to this particular location, and then what the agent would see in this position, agent is not seeing anything. There is no problem because here you see that there is no perceptor is not providing anything. Now you can take any place, anything to go, and here therefore you see that moving this point is also okay, and this point is also okay. Here you see that this is also okay, and this place is also okay. Whatever location you wish, you can go from here. Okay, so let's assume, I'm telling, let's assume that you took a path that take you into upside. Okay, by randomization and whatever you took that, you go up. When you go up, what you saw that there is a breeze, there is a string, and when there is a breeze, then when there is a, I think there is a breeze and there is a string, and I think gold is there, therefore glitter is also there. Okay, let me just see. So there is a string, breeze, and glitter is also there because of the gold. So when you see the glitter and you have the percept for the glitter, it tells you that gold is here. Therefore, you would say that grab, and therefore it is grabbed, and your task is done. Now you can come back safely. So this was one thing that I wanted to tell you, that it's not that difficult to see. So this is how the logic is applied. Okay, in the while you are applying logic, you see that sometimes there are some temporary variable that need to be maintained, and they are using some of the available information, you can find out whether there is a safe to go ahead or not. And if you find out safe, you can go ahead, find out the solution, and you are done. All right. Okay, let's assume that when you go into this place, what would happen? If you go into this place, you see the breeze, then you would be having a problem. It may be possible here, because it can be anywhere into three places. You would not go forward. What you do in case, as I told you, na? So in case I told you that in case you moved into this direction, in case you have moved into this direction, then here you would find out the breeze, this breeze, and therefore you would come back and you would go into this direction, and you are actually solve the problem. So this is all about this, and hope it is very clear and should be clear that how we can perform this kind of simple logic to find out the things. And the next topic that we want to bring into your knowledge is actually the formal way of representing the knowledge, and some way to come up with the inferences. Okay. So in the knowledge base, we understand that there are sentences that are written according to some syntax that are specific, whether they are well formed or not. Means when somebody has written using the syntax some sentence, if somebody has written, then I can find out that whether they are well formed or not. What is well formed? Well formed, do you understand? Well formed is this, that when you are writing a C program, whether your program is syntactically correct or not. Okay, well formed means syntactically correct or not. So because syntax is provided to you, but you may be writing something and that is violating the syntax. Therefore, if I give you a sentence, immediately you can find out it is well formed or not based on the syntax. Is it clear? This is the important part. Means whenever if there it is not well formed, then you are not going to touch that formula. You are telling that it's garbage. Throw it away. So because somebody can give you some sentence, and sentence can be wrong also. So if sentence is given to you, first thing that you want to see that whether it is well formed or not. When it is well formed, then and then you consider this for the logical inferences or utilizations. Okay. Then you have to define the semantics. Okay. Whenever there is a syntax, then after syntax there is some semantics. What is the semantics? Semantics, you understand both involved. It's a very important part. Semantic is the understanding that what does it mean. For example, if I allow you that you can write into x plus y is equal to 4. If I allow you, okay. So what is this? It is a syntax. Because sometimes I can also write a different syntax and hope that you know this very simple syntax and you know this now. Okay. Let me tell you another syntax. It's two syntax so that it becomes easy for you. If I say x plus y is equal to 4, this is one way. Okay. I can also say x plus y double equal to 4. So what is the difference between them? Okay. In one language, in one understanding, if I write x plus y is equal to 4, to which language actually accept this for the testing? Okay. Can you name any language? Python. Python. But into the other language, if I, for example, if it's a C language, C or C++, then I cannot write like this. I have to write double equal to say that I want to say x plus y is equal to 4. And what is the semantics? Semantics means that I want to test what is the value, whether x plus y is equal to 4 or not. Let me give you another example. If I say x is equal to 5 means what? This is a different meaning. It means that now whatever, let's say x is equal to 10. What would happen? The value of x would become 5. This statement would make value of x equal to 5. Okay. Now here the meaning was different. What is the meaning? That you want to test that whether they are same or not. But here what is happening? That this value is assigned to this particular thing. Okay. So this you should understand. And what is the thing that is making this difference in front of us is the semantics. Okay. Semantics in both the places is different. Here the semantic is earlier the semantic. Here the semantic is different. If I write x is equal to 5, 4, then the semantic would be semantics would be different. Okay. Now very simple thing, that is very simple thing, that this statement is true if x equal to n and y is equal to 3. You know this. But it is not true when x is equal to 2 and y is equal to 3. Okay. So there could be various values of x and y that would make this thing true. Okay. So therefore we can call that this thing is a model. Okay. And what is alpha? Alpha represent what is the assignment of this variable. X is equal to 1 and y is equal to 3 is an alpha. It tells that this is a sentence. That tells for this model this is the sentence. So this is a particular assignment. If I write like this, alpha of m of alpha means all the models where this particular thing is going to be work. And this is a very important part. I think it is not very difficult to understand that m alpha. However, it is very strange concept that I am going to tell you. That if I say that x is equal to 1 and y is equal to 3, and I find out m of alpha, what does it mean? Alpha means x equal to 1, y is equal to 3. M of alpha means all the things where this thing is going to give you the true things. So you can write this equation x plus y is equal to 4. And can you give me another equation? What I'm telling? I'm telling this thing, that I'm telling that x is equal to 1 and y is equal to 3. And then in this situation, if I want to find, and this is alpha. Alpha specifies this thing. If I want to find out m of alpha would contain x plus y is equal to 4. So can you give me anything else? Yes, x multiplied by y plus 1 is equal to 4. This is also a thing. And I can say that y minus x is equal to 2. This is also a thing. So similarly, you will find various models where this is going to happen. All right. So this thing is m of alpha represent the set of all the models for the alpha. Okay. Sometimes then very important concept is this, that we have something and there is a term called logical entailment. Okay, what is logical entailment? Means given this statement, I can find out this. Okay, there is some alpha, and alpha actually derives something to beta. Then we say that this is a kind of entailment. And if alpha divides beta, means alpha is beta is going to be less restrictive. Okay, because if something abstract you are going to take out, beta is going to be less restrictive because alpha is deriving beta. So all the things which are all the functions which are actually applied on alpha on the beta, say, they would also be applied onto the alpha. But there could be something that is not there. But if finding this thing may be difficult, there could be something. So therefore, if there is an entailment, means alpha derives something, then we can write that m of alpha is subset of m of beta. You know this. So next thing is this particular diagram, and that we will discuss after the break. So let us take few minutes break, and then we can start. And let me just give you some idea so that you can understand this. You would be understanding this into the next session in more detail, and that is very simple thing. This diagram is very simple but very important. What is the representation word? The representation is word that what is happening inside the model. Look, representation and the word, these are the two important things that you should understand, and they should be quickly understood. But what I mean by this, look, whenever you have an agent and there is an environment, and agent is going to perform some operation. How agent can perform some operation? It has some understanding that what is outside there. Understand, na? It has some understanding that what is outside there. So if that understanding, how he had gathered, that understanding he have gathered based upon some of the percept, some of the action that he have done. Okay, so that is called the representation. That is called the representation. Whatever he understands, how he represents that, what is the word. But actual word is actual word. Okay, so what you think that this representation should be equal to the word, na? Yes, at least you can say yes at this moment. No, if you find it difficult, then that is expected. Correct? That is expected. That yes, all right. I am happy that you have written this. You are with me. That there is some word. In word there is some things are there, and now I want to represent this into the knowledge. I mean, knowledge is also representing same things. So then only he can take the decision. Percept is telling something, then he can modify the things and take the decision, go do perform these kind of operations. So representation is there. I am not telling they are same. So, but they should be same. They should be same. It is expected. We want that they should be same, but they are not same. Why they are not same? There are two reasons for this. First reason, that this representation has been built based on some knowledge, and that knowledge maybe something is provided as an axiom, and something it has by itself derived by doing some of the interaction with the environment, something he had developed by himself. So these things he have developed. So therefore it is not the complete information. Since the complete information is not given, therefore representation cannot be correct. Are you okay with me? Do you understand this part? Since all the things are from the environment is not given to me, how can I represent the complete word? Therefore this representation is different. Number one. Second part, the word looks complex, but sometime I can give you that, take this thing, give me a simplified version. Sometimes you can make a simplified version or not. Possible? Are you able to see this? In automata theory, you may have seen that there is these number of states are there, these many number of links are there, and they are performing some operation. So it's a kind of circuit minimization. So can you minimize the circuit? Maximization also, ulta bhi ho sakta hai. So there is some circuit that is performing some task. But if I ask you that give me how this is done, you can give me the minimal version also. Are you with me? So you can come up with that answer also, means because you are developing from the zero. So instead of the word, you find out the better representation of the word, or the worse representation of word. That is actually that is aligned with your whatever percept you have taken, whatever knowledge is given to you. That is aligned with that. So therefore the representation and words are different. Are you with me? Is it okay? So I would be taking a break at this moment, and hope you can understand and come up with a better question at the into the next session. We will be starting at sharp at 8. Okay, it's a 10-minute break. So in between, if you have any question, keep asking. We can address them. Okay. Thank you very much.